welcome to our technology webinar. And we are going to have this new format where we're going to discuss in details some peculiar part of the converting project. Please do not hesitate to ask questions on the chat. We are going to reply at the end of our presentation. For you who don't know me, I'm Lorenzo Lupi, Vice President of Sales and Marketing of United Converting Tissue. Today we're going to discuss some details of what's happening during the cut, especially cut of high density products. And for the reason, Max from Blecher joining us. Again, a small introduction of United Converting Tissue for the ones of you who doesn't know us. We are an Italian engineering company that is specialized in the production of converting machines for rolls and folded products. We have more than 100 complete lines installed worldwide with 100 plus integration of single modules, which the vast majority of which are industrial logo. Our company mission is very simple. We want to help our customer to be successful. And the vision on which we do this is to simplify tissue converting. Now, Max, thank you for joining us.
Thank you. Thank you for being here or welcoming me here. Thank you all for waiting for us. Again, sorry for the technical issues what we have. But shortly to myself in person, my name is Maximilian Ulbrich. Maybe you know me, maybe not. Maybe you know our company, maybe not. But shortly, a quick review. We are the Ulbrich Blecher GmbH and Co. KG. We are based in Remscheid, Germany. We are now older than 165 years. We are producing lock-saw blades, grinding wheels, and as well perforation blades and lubricant. 100% everything from Germany. We can build up with it 360-degree solution package, which is quite nice because it's getting, let's say, rounded by our technical support, where we are going out to the customers, setting up the machine, parameter, etc., and trying to increase the output of our customers, which in most cases went very successful. And of course, that's why we are here today, because we figured out during that technical visits a lot of problems pending on heat. And I guess Lorenzo will now tell you a little bit more about that.
Thank you, Max. So the reason why we decided to start with this topic first is because going across most of our customers in Asia, Europe, and North America, we get explained a sense of transformation, especially for independent converters of SKU that they are making. Companies are facing two major problems. One is being labor shortage that is not only affecting manufacturing itself, but is affecting also the HoReCa industry and the facility management and also the logistics. Only in Europe, we are estimated that we are short of 400,000 drivers. This transforms the requirement of the finished product, making it more and more popular to have higher density products. It used to be a niche in the market, but we see in all the market that we are present that is becoming a more and more part of the SKU of companies. And this creates challenges by itself on the logo part of the converting process. Now, we made a name for ourselves with our logo since 2004 when we started the company, but we reached kind of a limit a few years back, where it doesn't matter to make a bigger frame, it doesn't matter to put bigger motor, the end result were not changing much. They were not changing much because the limit of the machine became the blade itself. That's the reason why we start discussing with Max and understand what is actually happening in the blade during the cut.
Right. So I want to start a little bit more on the base of the blades. So actually, what we're talking about a blade which is made of D2 chrome steel. It is in 12% chrome steel. It is martensitic microstructured steel. For our side, we can say that we are getting supplied very close to our company, 100% from Germany, where the steel, and there it starts where, let's say, I would say the magic happens. Because our steel gets cross-rolled. That means that when the steel sheets getting rolled out, they are rolling them, flipping them with robots, and going again through the rollers. In that case, we are very sure about that we kind of not stressing the blade in the wrong direction and not changing the atomic structure too much. As well as that, we are coming to the hardening process. Close to it is also a very important subject about it. Right now, we are reaching hardnesses of roughly around 62 HRC, where we are mostly focusing about. Talking about that kind of hardness in D2 steel is quite unique. Because it is very, I would say, very difficult to make it running with 62 HRC, because usually the problem what you have from the D2 steel is that you can't straightening it anymore, or it's breaking or whatever. Often people trying to use sharp hammers doing the smithing, what you will just find with in Blecher blades just up on 6 mm. Because below we set part of our quality control and quality sign is that we are only hammering with ball hammers in that case. As well, another part to not stretch the material too much is that we are having developed a new grinding technology system where we are not stressing the blade too much. So we are giving not too much force to it and not too less, of course, because we need to produce a lot of blades. But a different lubricant, and inside there are quite a few changes since the last, I would say, a couple of years where we developed ourselves very well. Coming now to the part what we are mainly want to talk about, what happens when that kind of steel, what I explained now, is getting into physical exchanges. What I mean with this is that the friction, which is going into the blade by the cutting process, is transferred into heat. So now we're talking about the heat problem. So when firstly we are talking about problems of heat, it's like for the blade, I can say roughly, because we're talking about the Martensitz steel D2, we are talking about problem area 50 to 60 degrees, roughly until 80. In a few, let's say, parts, you can say, okay, for that type of product, it's working. For that type, it's out of the spec. What we are, where we can't wear the stiffness anymore of the blade, and where you have to find some, let's say, some things to change it, that it keeps running. As you can see in the chart, maybe what we have is that we having quarters out of the specs. There you find the heat area, second, let's say a second, third, and fourth area. In the first, if the heat always be in the first area, what we want, that we're talking about roughly 50 to 60 HRC, 50 to 60 degrees. We will not go too much to the center where we have the support rings, what we was rolling in for the tension. Right. Then of course, we see as well that and that part, the critical area on the blade is not the pre-bevel, it's not the bevel itself, it's the point where the pre-bevel gets to the bevel, because that point takes all the force by starting cutting into the lock. And from there on, we are spreading all the heat to the center of the blade. So the problem of that part is, yeah, let's say mainly to avoid it, okay? Because as more as we are coming into the center, as closer we are coming to the tension rings. It's nothing about hardness so much. It's nothing about anything else. It's more about tension. More we are coming to that, the problem of the heat starts to grow, because what happens when you're heating up metal, it's expand itself. And as we was pressing with a lot of pressure before inside the blade, we are losing the tension. And as we already changed the, let's say, areas where we are making the tension, we're making them already more to the center side, let's say, and changed a few steps when we're doing what step. We are just sure at a certain degree that we will catch them, and you will lose the tension. So the blade starts vibrating. Everyone knows it. It starts vibrating. Then maybe it starts clocking between the grinding wheels, and in the end, you're getting a stop sign out of your machine. Yeah.
Thank you. I've always been personally curious about this topic. I have chemical background, and it always confused me because metal characteristic doesn't change much between 20 and 100 degrees, but that's the reason why we got vibration. Now, I guess everyone face this issue of heating up the blade and having poor quality cuts. We came up with some solution that improve the cutting quality in our new Unicode 365 log. We had this development where we tried for many years to keep the blade cool, or actually cool down the blade. And a few years back, we tried to look at the problem on the reverse way and see maybe we can prevent the blade to heat up. So we made some orbit study and see what happens during the orbit of cut. And we found out that giving 100 the time that the blade spent inside of the lock, 60% of it is to actually cut the lock, while the other 14 being orbital lock, so it's just blade completing the orbit and coming out. So what we're doing, basically, we take off this 40% with our new clamping system, and that's reduced the heat transfer to up to 25%. Now, as part of preventing cooling the blade, preventing the heating, there are also other solutions that Blecher is developing, and then Max will share with us.
Yes, actually, we improved the new coating. So we thought about how to avoid critical areas when we're talking about heat. As I told you before, we are coming also from the saw business. And there we already used a type of coating which is called like chrome coating, very roughly. This chrome coating, of course, you cannot apply directly to a log saw blade. So we changed a lot of specs on that it can be applied on a D2 steel as it can be applied on a CV steel. In the end, what we got out is we are having now a layer on the blade which is saving your blade from the heat which is coming by friction into the or which is trying to get into the D2 steel by the friction. As I told you, we are not talking about the pre-bevel, because the pre-bevel gets always sharpened. We can't control it with a coating, but we can control the end of the tip or the side of the tip, wherever you're looking from which side you're looking. So the thing is, what the chrome coating is doing, it is taking the heat to its own surface, let's say, but not bringing it into the steel itself. So we don't stress the material by forcing it in a very, let's say, heated up action. But on the other hand, of course, as we are working also in the UCT machine, for example, with a lubrication system, the surface quality needs to be also a little bit rough so that the lubricant can stick still on the blade and is not flipping off like when we're using Teflon, for example. So in that case, we developed that chrome coating and was able to cut certain diameters with certain tension.
Thank you, Max, for sharing this, and I hope that that part was clear. Yeah, sorry for the technical issues. We are supposed to share some details that support our claims, but we are going to send it by mail. So in the meantime, if you have any question, please do not hesitate to ask. We have been working with Max in a few projects now where we reach, I think, astonishing density of operating at 300 kilos at 350 millimeters diameter in production, which I think so far is a record for a meter blade also.
Yeah.
And so if you don't have any question, we will send you the information.
Yes.
Okay. So just out of curiosity to warm up that everyone hear us everything because we had a crash before we started. Let me see if I see that. Okay. So I was saying that the new performance that we reach with our log, so you can find a new simulator that we prepare on our webpage. Now we're going to share it to see how it works. So I see. So yes, on the United Converter website, you can find a simulator where you can see what our Logso is capable of doing. And the reason why it's capable of doing that is because we can reduce the blade heating. I've been very successful in many, let's say, border products, reducing both trim size to waist. So I'll wait for questions.
Yeah. So please, if you have some technical questions, please share them to us. Maybe you can share some cases where maybe one of you also forced problems with vibrating heat, whatever, and we can maybe clarify, even if it is out of the subject of today, as we're sitting now here together. Maybe you have some issues which you want to share, or maybe some questions generally, which we can maybe answer. So please do not be hesitate.
So the last product was the chrome coating that you sent.
Yeah.
Okay. And what bevel did we use at that? The angle?
I guess we used an 15 degrees angle.
Okay.
Because depending on, I mean, you told me what we want to cut. Of course, maybe this is another subject which is quite interesting because depending on the cutting product, what you are right now cutting, we are deciding, even in that case with UCT, we are deciding what cutting angle we will use for your paper, because the entrance angle into the product is very important. You can calculate it with, let's say, a lot of knowledge and, let's say, collected data, but on the end, you don't want to rip it off like with an axe, and you don't want to slice it like a tomato, so it needs something between it. So that's what we are also doing. I mean, that is part of both of our technical support to, making something what is fitting for you guys.
I think that's one of the few things that are always fascinating about this industry, that everyone try to do something different.
Yeah,
And actually, with
definitely.
different paper, there are different needs.
Correctly.
So the fact that to be able to share experience within this industry, which is a very very close. You see that exhibition. You see, well, here in Luca, especially. It's nice because you don't need to be one single stop of Nischenstein, but you can share experience with experts. In this case, Blade. And what we're trying to prepare is a series of webinars where we define one problem at a time. And I hope that you like it. I don't see any question. I think we can shut it. Thank you very much, everyone, who joined us. We are 32 viewers, which is. Oh, that's Mr. Steve Matthew. I'll. So thank you, Mohammed. So we'll try how to identify problem areas of heating. Can you please explain that again? I think that's your bit.
Yeah. Actually, we was locating the heat areas with an IR camera system. That time, the problem on IR cameras, of course, everyone knows, if you're trying to catch something what is reflective, you are just measuring the, let's say, the temperature in the room. So for that one, we used a special coating with an, let's say, with the same RA or with the same surface quality what we are producing from the blades, so that we are more or less can guarantee that this is to 95% the heat what we are usually generating. So we added 5% on the heat to just be sure and make it, let's say, a little bit more critical, and for us, so that we can ensure if we are sending you a blade that's fitting your needs. To figure it out directly on the machine, as I told you, if something is reflective, it's very hard to measure it. So if we are talking about like a big project, of course we can do it. We can send a coated plate with the special coating we had that time in the IR camera, and seeing, depending on the paper what you're producing, we can definitely figure out where are the heats right now. That is possible.
Okay, thank you. Again, we have a new question from. I need the good eyes. Sorry. Hello, Max. Do you recommend thicker blades, 4.76 millimeter, for cutting high density recycled paper rolls, or thinner blades? Thank you, John, for the question.
Actually, in that case, I would recommend the thicker blades, as the thinner blades can heating more up. Of course, in recycling, you have, let's say, a little bit more air because you have so many other things inside the paper than pulp. But usually, I always recommend the thicker blade. The thinner blade I used to recommend for facial tissue.
Yeah, when we had this experience, especially in our experience, it depends out on the emitter. on the finish lock diameter. Thinner blade eat up fast, but of course find less resistance in the lock. So if you have, I think, up to 180 millimeters diameter, thinner blades will compensate the disadvantage of eating up faster because it's thinner, so there is less steel to share the heat. More than that, the thicker blades still held its advantages. Now we have another nice, interesting question from Nadzin. See, how can you calculate the difference of the angle between the dense and the soft rods?
Yeah, actually, this one is a little bit, let's say, a tough question because usually you have a fixed angle, which you cannot change. Let's say 99% of the machines, except maybe all the machines where you also can adjust the angles. What we are recommending is that for especially let's say until 710 millimeters, that's something over the sum. Everything what is until 710 millimeters use 14 degrees, and everything over it's like 15, because the most, let's say, very dense products will be cutted after it, and even from the entrance angle when you are calculating the angle even of the bevel, that is also a part out of it. So you're using, for example, on the 610, 190, 230, 210, whatever your bevel is. Also, this is depending.
So basically, it's better with lower density if the diameter allow it to use smaller blades, which just make the cut easier. Anyway,
Correctly, right. Yeah.
I think it was very interesting question, and hope that we answer us that up to your satisfaction. Yeah.
Yeah. If you have any more questions, for example,
Sorry, this is very little. So, what type of refrigerant lubricant do you recommend to prevent blade eating up? Yeah.
actually, the AB40 from Blecher, of course. But yeah, the thing is why I'm recommending it is really simple. As we are having a lubricant which is based on glycol, and glycol is the same thing what you, for example, use in the AC. So the benefit is that even if the blade starts heating, you can reduce the heat by spraying the lubricant on in a consistent way. So I would recommend an AB40, but in any case, a spraying system is always better than having no spraying system. So I'm very open on that point.
So, actually, another interesting question from Sven is how important is the resharpening process with grinding wheels?
Yeah, that is actually one of the most important questions, because from my point of view, I mean that's also something for you. I don't want to always explain it.
Well, I mean,
I'm leaving you
you're
there.
an expert in blades. I'm an expert in, well, something else.
Yeah, actually, the resharpening process is very important. Actually, the steps between the grinding wheels, when I'm sharpening, how long I'm resharpening, you can calculate by the spinning of the blade. You can calculate, for example, by the meters per second the blade is spinning. You can calculate from that point out of how long the grinding wheel takes until it reaches the same level of speed. And when it reaches the same level of speed, the grinding wheel is not anymore grinding, so it's not taking any more material out. If we are talking now a little bit deeper about CBN stones, CBN stones are chemical man-made diamonds founded in the 80s in America. And the thing is that this is not a grinding, it's a honestly cutting process. So you're grabbing out the material out of the blade. And yeah, to answer that question very quickly, it is a very important thing, and the adjustment of the grinding wheels is the key.
Thank you. I mean, from our part as machine manufacturers, say the way we develop, we do grinding, so the mechanics, the software, it's probably the most difficult part to design in a log. So one, because it's very small, so everything it's need to be very precise, and second, because going back on the original subject, which is heat, you need to grind just as much as needed. Because if you're over grinding, then one, you waste blade for nothing, and two, you transfer a lot of heat.
Yeah.
But on the other side, if the grinding is not done as close as possible as being perfect, then the resistance that the blade find on the log is much higher. Then again, you have heating problem. That's the very crucial part. Mostly, say most of the time where someone is expecting issues on the cut is because the grinding had some sort of trouble. I think we have a new question from Nanzine. So I can repeat.
Please go ahead.
So basically, what we discussed have been there are two angles. They are similar, but they increase efficiencies. So you get to use 14% up to 710, 770 millimeter blades, and 15% on larger diameter blades. That's the ideal setup. And I mean, please do not hesitate to write us an email if you want it in writing.
No. Even if you're very interested in that we are maybe looking a little bit deeper into it, you can send us the production, your product specs, and we are can look it over, and we can develop maybe something for you. I don't know what cutting angle you are using right now, but from our point of view, from a blade maker side, it's like that.
I see.
The
degrees.
Sorry, yeah, it was degrees. It was like 14 degrees until 710.
Yes.
And 15 degrees, everything what is up then 8. So there are certain diameters like 610, 635, 630, 700, 710. There are so much. So everything like this is 14, and everything upper we recommend 15. Is from the part of, let's say, knowledge we gained over the last years, both of us. And we definitely agree on that.
Which in your case is 165, which you look much younger than that, by the way.
Yeah, for 165 years, I'm still looking a little bit young, yeah.
But yes, then again, we are going to send some charts that we were unfortunately unable to show during the presentation, but we will be working on our technical issues for the next one, and we're also going to send you a recorded version just in case you missed something or you want to share it with your team. But then, of course, any specific information, you have our contacts. We can organize a video call one by one anytime you want.
Yeah. So thank you very much also from my side and from Maurice Blecher. Hope to hear from all of you soon. And again, if you have questions, please let us know.
Yeah. So again, we have a new question. If we have a problem on the cutting, yes, of course, you can contact us. You have our contact details.
Yeah.
And I hope that you have a better understanding of what's happening in the cutting process with this short webinar. Yeah, we try not to be too boring, but for someone like us, which get excited about toilet paper, is very difficult to get bored. All right.
Yeah.
Thank you, guys.
Cheers.
Bye. Thank you. Bye-bye.